I have to tell you the secret behind the title that I composed. When I was a little boy, I found out that I was annoying my father. My father was a very, very special veterinarian. I was annoying him with the question, what does it mean, a particular word? Obviously, I was learning the language, in my case, Romanian, and questioning, what is the meaning of this? And one day, I must have been in second or third grade, my father came home with a 4-volume set of the dictionary of the language. And he said, boom, drop them on the table, look them up. So William invites me and Garth to the symposium, and I said, wait a second, I'm hearing these words for the first time together. Thermodynamics and emotion. I teach thermodynamics, I know what that means, but what about emotions? And of course, I checked my background, I know what those words mean, but I also checked the dictionary. And so my objective today, in other words, my presentation, is about explaining the meaning of these three concepts: constructal law, thermodynamics, and emotions in this sequence. And then, hopefully, when you put those three together, you will have been persuaded that they belong together, and that the organizer's vision was actually brilliant, you see. This is a first in science and other domains. Okay, so what are these things? Oops. Constructal law comes from the obvious that surrounds us, images. Without images, we have nothing to see or remember or talk about or to dream about. So images are, you see them, you know what they are. They happen to be everywhere. That's nature. The meaning of nature is that. It's the everything that is, what happens by itself. From Greek, the name is physics, or physis in Greek. And the image in this example is the same, inanimate, the river delta versus the cast of the human lung, which means animate. Look, in science, things that happen the same way, billions and billions of times the same way, represent one phenomenon. And it's a phenomenon of everything, which is a phenomenon of physics. Not of biology versus geology, but of physics, like gravity, or the conservation of energy, or the phenomenon of irreversibility, which is called the second law of thermodynamics today. And because people don't have huge brains to accumulate all these billions and billions of tidbits, people naturally condense the similar into a very brief statement. And that brief statement, as you'll see shortly, is the constructal law. But before you get to the statement, I'm introducing you to the idea that you know already what the statement is. Because Kevin, you're talking about feeding your horses. I grew up around horses myself. You see river basins forming under the horse every time the horse discharges. So, yeah, and the pattern that strikes you is a river delta. There's a river delta not only at the end of the Danube, but under every horse. Or when you spill the milk on the kitchen floor, especially if the floor is beaten dirt, you see this pattern. This is a simulation in the laboratory at Colorado State University of a river delta forming over time on a surface this size, perfectly flat, covered with sand. And from one frame to the next, the river basin is, by the way, so the rain is falling on the green, the water is exiting the floor through one end, and one end only, and it's always a tree, this pattern of channels, but the tree is flowing more and more easily. In thermodynamics, more and more easily means Yes, it is flowing, it is driven, and it is driven by a force that in the case of river basins, it has to do with the altitude of the hills relative to the level of the sea. Over time, the hills that drive this flow are getting smaller because of erosion. So that means easier and easier flowing. Same flow rate, smaller force that drives the flow. And, the big message here is that the images around us in nature are actually not still images, they're actually movies. There is a direction in which the movie tape is running, and is not to be confused with the one from left to right, which is the correct one. And change in flow configuration is necessary in order for this tape to run. Freedom to change is absolutely essential. And the movie tape is running without end. That means evolution never ends. And at the bottom I have, now again going back to my father's dictionaries, the that evolution, the concept, which I claim belongs in physics, not in biology, has nothing to do with Darwin. Evolution is a word as old as Western civilization. It comes from Latin. The verb evolvere means literally is the opposite of revolvere. Evolver is to roll out, to roll forth, like the fetus out of the mother. Here we have the image that's also responsible for the word natura, or nature, which is she who gives birth to everything. So the universality of the phenomenon of evolution is in the word. Okay? That is the way I think. And with that background and imagery in mind, in 1996, a story goes with this, I sat down and wrote the physics definition of life, which is that for a finite size flow system, well, I showed you the flow system, it is finite size because it has contrast, it has black on white. It is not about one molecule or one subparticle by itself bouncing or not in an empty box. That is a drawing without configuration. It is a drawing with evolving configuration. For that to persist in time, that means to live in physics, it must evolve freely such that it provides greater access to its currents. That's pretty obvious when you think about the river basins, where the lungs, the vascularized tissue, the lightning, the galleries dug by earthworms were paths of migrating animals through the bush. So the Constructal Law is the definition of life. It is also the physics definition of the time arrow of change in nature, which is in fact the meaning of evolution. All right, so I showed you the experiment with the river basins. I think of everything that moves from the atmosphere to oceanic currents to these other things that move, these buckets of water called animals. I think of them in the same way. So animal life, the biosphere, is with regard to movement and evolving flow architecture on the planet, no different than all the other evolving flow architectures, all flowing more easily to churn over the Earth's crust more effectively, more easily, more impressively. Okay, so rivers of animal mass. In the late 90s, just 2 years after stating the Constructal Law, I used the idea to predict that all flyers, from the insects to the airplanes, look at this immense one-side range, should line up according to a tiny formula which is written up there, which comes from the Constructal Law. After the theory comes the audacity to put together the entomologists with the ornithologists and with the aerodynamics engineers and conclude that unwittingly everything that moves has been reading my book on how, you see. Thank you, sir. I had no idea I was talking about a big idea. Okay, so that's the rivers of one moment of excitement invited reenactments of that. So I showed that the same prediction holds for runners and swimmers. In fact, all these movements are the same. The only thing that changes is the ambient through which the mover makes horizontal progress on the globe. The summary of it, written now as a narrative, is that, meaning it's worth keeping in mind that larger animals should travel faster. Key word in science is the word should. This is the pronouncement, like one of the Ten Commandments. This is the way things should be. Everything should obey this trend or this tendency. Larger animals should travel faster, should wave their bodies less frequently to give the impression that they're lazier, which is a wrong impression. They are stronger. They should be stronger, meaning they're stronger weightlifters. They should move more mass to greater distances. That means they should be bigger trucks or machines for moving freight. They should live longer. The lifespan of all these things that move these animals, including people, are predictable from the Constructal Law. And they should travel farther during their lifetime. That means that the bigger animal scribbles on the earth a longer squiggly line than during the lifetime than the small animal. And the animals, in fact, are no different than the athletes. The athletes all training and basically competing against one another are a small laboratory of animal evolution, a laboratory that's actually wonderful to study and to know, because in athletics the objective is one. Unlike in animal life, where biologists would tell us that the objectives are innumerable and oftentimes contradictory. Well, anyway, it turns out that the one objective of the athletes is the same as that of the animals. If you want to know more about that, I'll comment later. So I had time with this question about athletes, and I was able to show that yes, over time, and time runs along this curve to the right, over time winning speeds in the Olympics and the World Championships increase. Remember the comment that the records are meant to be broken. Well, it takes a lot of evolving in training for them to be broken. And so this winning speed increases over time, but less known is that hand in hand with that, the sizes of the always different winners that climb on the podiums also emerge to be larger. When you do the statistical average of these winners, you will land right on top of my previous solid line, indicating that runners on track are no different than runners in say, the South African bush. Same with the swimmers. And this, in fact, kind of completes the circle. You see the oneness of everything. Do you see any difference between the previous slide and this one? Yes or no? Yes, I do. Well, the answer is yes. These are all of African origin. These are all of European origin. So, yeah, that's right. So we have now a segregation happening on the winners' podiums. And there is a reason for that as well, a Constructal Law reason. As you'll see very soon, the speed advantage belongs to the body that falls forward from a greater height. In other words, the telephone pole falls forward faster than my pencil. And in running, no, wait a minute. In running, what falls is the center of mass of the body, which in the case of a runner with long legs is actually higher than in the case of a runner with short legs. Use your imagination as to how legs are long versus short in the bodies of this diversity of humanity on the globe. That distribution is very clearly associated with geographical regions. Okay, and here the opposite is true, or the same idea is true. What rises and falls in the water is the torso, and so European bodies have longer torsos, shorter legs. From this, the advantage in swimming. Another way to summarize this is that, again, through the simple act of behaving like an amateur, this is Adrian, who knows only one thing, which is Constructal Law, I end up answering questions that have not been asked. In fact, I'm predicting or saying, gee, you know what, this is why we're seeing that among the fastest are of one kind in water versus on land. And from this, a comment on the biosphere, the way it has evolved. Legs are for land, meaning for walking and for running. Torsos are for swimming. This is why the fish has no legs. Yeah. Okay, so now one of my students made this animation on the right to show you the difference between a tall stick falling forward versus a short one. The time, the duration is the same. You see that the taller has made greater progress. Turns out that a stick that falls only 30 degrees forward makes even greater progress. But you see the taller one is still faster than the shorter one. Some of you may recall, say 20 years ago, there was this fantastic sprinter, Michael Johnson, who was winning every 200-meter sprint. His record persisted the longest in the history of track. And this was, I met him, in fact, a runner who was running standing straight, not falling forward much, taking many steps, and running like a vertical stick. Well, this is why he was not beaten, because he knew, or he discovered by birth, that faster meant falling forward almost vertical. That is when the forward falling speed is the greatest. It's when the stick is almost vertical. Okay. So that's the first third of my presentation. Now thermodynamics. Thermodynamics is a great science that came together exactly 150 years ago when two currents or lines of thought in physics were discovered to be in fact about the same thing, which was about energy and the fact that one form, which was heating, can be converted into another form, which was working. Working was known very well from the field of mechanics. Heating was known very well and very usefully and successfully from the so-called caloric theory. You know about the other way, which is to convert work into heat. You rub two sticks, you made fire. Friction was known forever. So that's one way to convert the work into heat. But the other way, which is only 200 years old, or a little more than that, was discovered through the invention of the steam engine, which was to make work, or per unit time power, from burning a fuel, from fire, you see. So thermodynamics, to those who have my background, is about therme, which in Greek means to heat, and dynamis, which in Greek means force. In the history of physics, people did not talk about energy or work. They talked about force. Well, force really means, in today's physics, work or a force that moves something from one place to another. And in fact, this is the, you see 3 words in my summary of thermodynamics. The third one is never mentioned, as I'll show in just a second. The work is, in fact, spent immediately for the purpose of moving something against the opposition of the environment. For the same reason, the work that eventually is rubbed into heat comes from moving something, you know, my hands or the 2 sticks, you see. So thermodynamics, the title of it is good, but it is incomplete. Motion belongs in it. Without it, there is no reason for producing work or producing heat from work. All right, now all of us are living and moving, especially in today's advanced world, because of this phenomenon of the convertibility of heat into work. We live in the blue space. I could put some pictures of people there, but you can imagine them riding on a horse or riding inside this Citroën. Into the so-called system, the word for anything in thermodynamics is system. Think of it as a black box. Into any black box comes heat from burning a fuel or an amount of food, or accepting, say, heating from the sun. Anything that we call today as a flow of energy comes into, as heat into the system. The system is an engine, operates as an engine because it produces work, or work per unit time, which is power. The difference between work and the heat that came in is the heat rejected to the ambient. This is, in fact, the story of thermodynamics, if you go to school and study it. However, there are 2 things that are not mentioned. They are the fact that in the space of interest, we are it in the space. These so-called black boxes actually have configurations that change over time. They evolve. You can see that the movie from domesticated animals. I did not draw the slaves, but from this direction to that direction. That's one thing that's not discussed, is the evolution in the blue. The other thing that's not discussed is, once again, the movement that's driven by the work that was produced. Like, show me the money. Well, the money is not the work. The money is the fact that stuff was taken from here and moved somewhere else. Okay, the first thing that is missed is the so-called evolution in the blue space. I drew here that rectangle on the left, upper left corner is a system. That box is not changing. Imagine, it's not a change. It's like a bird cage, and into the cage blows the wind at constant speed. The same wind exits to the right. Nothing is changing, except that in this movie, which nature is, from the time of the Egyptian galley, the inside of the box has changed to the time of Columbus. And over here, this is the time of Napoleon. What has changed is the configuration through which the moving atmosphere engages on the surface of what is not moving, which is the ocean. So we call this engagement the transfer of movement, called momentum, from the atmosphere to the water. In this case, through human ingenuity, better shaped, say, wood and sails in this floating object. The atmosphere is grabbing tighter and moving the ocean water better. In other words, equilibrium between the moving wind and the non-moving still water is enhanced or accelerated. But you don't have to imagine sailboats for this conclusion. The waves that happen on the water surface when the wind blows grow and orient themselves, first of all, transversely to the wind in order to enhance this better grip that the atmosphere has on the ocean. If you don't like waves, if you don't know waves, think of tree logs, floating objects, or tabular icebergs. They always or ships adrift, always orient themselves transversal to the wind. You can count on it. Why? Because nature has the tendency to evolve, to reshape, to reconfigure itself so that the neighbor engages the neighbor so that the two flow together. Obviously, that's the way to flow all the way to, in this case, to equilibrium, meaning no more movement. If you don't like ships, you may want to play with the history and the evolution of Peugeot cars. That's at the bottom. I had fun making that montage. And so that's the evolution in the blue space. Now, the second one, the second point that's not discussed in thermodynamics is shown here in green. These are the engines, ancient or contemporary. They take heat, they make work. Difference is the heat rejected to the ambient, but the work is not saved by anybody in a work bank. There's no work bank. The work is spent on moving stuff from Portland, Oregon to Washington, D.C. That takes work or power, and that work is dissipated into heat. You can add this fat arrow. Sorry, this fat arrow is the sum of these two fat arrows. And so the big box, the big picture of nature is what's in the rectangle with dashed line. It's very boring. Heat in, 100% heat out to the cold sky. But in the meantime, back in the States, because of, in this case, human ingenuity, stuff got moved from one spot on the landscape to another, and that is the way nature is. People, animals, the winds, and the ocean currents, all together, they exhibit the same tendency. All right, so that's thermodynamics. This is, in fact, what I just showed you, useful to know. At the very bottom, the complete summary of thermodynamics from fuel through contrivances we call engines today. But the older name for the engine is the animal design, or even older, because the Earth without the biosphere is older than the Earth with biosphere. The even older engine is Earth itself. Here comes heat from the sun. That heat is bounced into the cold space. And in the meantime, on the Earth's surface, you have all these flows that are driven by the Earth engine, and flows that dissipate the power that that Earth engine generates. So engine was not invented by James Watt. In fact, he didn't invent it, Newton invented it. But the point is, engine is nature. Nature, not human, invented engine. What people invented is the laws of physics that govern the functioning of engines. Okay, so fuel makes work. Work means mass moved to a distance horizontally on Earth. Well, but look at the movement. This is a NASA view of 20 years ago of where airplanes were flying on Earth. NASA was able to measure the condensation trails left behind all flying aircraft. You see here that movement on Earth is not uniform. The whole globe is moving. Watch, the group. Everybody is moving. Everybody and his little nephew is moving, okay? Like the red blood cells in the animal body. But sooner or later, in order to get from here to, say, Tokyo, these red blood cells have to flow through the heart. And the heart of this movement on the globe is Europe and North America. It has two chambers and one aorta. If you only have access to this image, you immediately figure out the history of North America, where it came from, and in other words, what movement sparked over the Atlantic in order to expand itself. If you're not interested in that, let's call it kind of discussion, then forget about Columbus and think about why this sort of movement developed its heart in Central and Western Europe. The reason is the Roman Empire, because the Roman Empire is where road building was implemented all around the Mediterranean perimeter. That was a mixing chamber. We hear about America being a melting pot. The first melting pot was the Roman army. And it was the result of that later, of course, enhanced by the spreading of the empire northward and what happened after that. This design is in place. The only thing that one can do with the physics is to predict its growth and its persistence and continuing increase in flow performance. But I'm actually digressing. Let me get back to the message of this slide. Here's the physics. At the bottom, the movement, which is this movement, is hierarchical, not uniform. It is unequal, you see. And the conclusion at the very top, it means that the burning of fuel on the globe has to be unequal, non-uniformly distributed. Why? Because this is the natural way to move everybody with less and less fuel, or faster if you want, at every moment. Architecture happens the same way all the time, meaning hierarchically, unwittingly, because everybody wants the same thing. Social organization is not an objective. It is the movie or the image that simply happens because all the participants, larger and larger numbers, wanted the same thing. And the hierarchical architecture is obvious not only in transportation, but how heating is generated for human life, cooling, so air conditioning, the generation of drinkable water. Hierarchy means few large and many small coexisting, basically like the architecture of the river basin. And you see that in the alignment, amazing alignment of all living groups in this two-dimensional graph. This is the fuel use annually in individual countries or groups of countries versus another measure, which is equally accessible, which is the annual wealth of those countries. So what economists call wealth, physicists call fuel use or movement. It is an important conclusion. It means that economics is a chapter in physics. Wealth is not an intangible. Wealth is not the money that you hide under the mattress. Wealth is money you spend for the purpose of burning fuel in order to move something with purpose. again, life is movement. We have already covered that subject. The movement, as I said, is hierarchical. I like to show it with this icon of the birth of the city block. This is the plan of the Atlanta airport. The desire of everyone there is to have access from one gate to all the other gates. The access is of two kinds, slow and short, which means to walk up half a concourse in blue, and then there's also the long and fast, which is to ride on the train. It turns out that the shortest travel time averaged over the entire area, which means the population of travelers, happens when the rectangle that you see has a special shape, which is a shape like a business card. Happens to be the shape of the Atlanta airport today, and is such that the time to walk on half a concourse is the same as the time to ride on the train. 5 minutes in Atlanta. Long and fast, in balance with short and slow. If you ever been to or through the Atlanta airport, then think about your own city block. To walk out of your home to reach the car is the short and slow. To drive on the first alley is the long and fast. Or if you live in another area without a lawn in front of your house, then to drive on the alley, which is in blue, takes as long as to drive on the next street that's shown here in black. So the city or urban design, something else that simply happened, is the result of this urge of everyone to basically to avoid the lack of wisdom of hurry up and wait. Always a balance between walking and riding. I started to question this when I was, in fact, in the very, very beginning with the Constructal Law. I was remembering the maps of old cities. For example, the map of Rome. In Rome, the city blocks are of two kinds. Right in the center of Rome, in the old city, they are square and tiny. They're like Atlanta airports with only one street and only one or two concourses. And the speed in the black and the blue in ancient Rome was almost the same. On the street you had the cart pulled by the horse or by the ox. Walking, we all know that didn't change much. And so when the two speeds are almost the same, then the shape of this business card is square, and with a small dimension, which is the dimension of the short walk out of your house into the street. Then, as the city of Rome expanded, you see on the outskirts of Rome, especially in the northern part near the Olympic Stadium, you see long, let's call them streets and not avenues, with lots of dwellings on the side. And the reason for that is that the speed of vehicles has increased greatly. In other words, the business card became more elongated or shallow looking. That's a boring design. That's why today, if you look at the developments, perhaps in this city and other modern cities, these elongated building blocks of the city are designed to be either undulating or convoluting, and designs that in fact look the same way, I mean like a long business card, if they are stretched, you see. So that's one way to understand the past, but also to predict the future, if you know this principle. The Atlanta airport is an icon because it is found everywhere you look. Freight is moved on the area the same way. Freight is in those trucks. An area can is covered by movement of these two kinds, long and fast, carrying the same stuff, and short and slow transversally. The second bottom rectangle is the food chain. Few predators, bigger obviously, moving faster and longer, coexisting on the same grass with much more numerous, smaller, shorter moving, slower moving animals. The river on the hill slope is the same design. Here is the river in the valley, and the water seeping into the river comes from the hill slopes. Inhaling and exhaling. Inhaling is the air rushing in through the airways into the alveoli. This is a drawing of the alveolus. Diffusion of oxygen one way, CO2 the other way, is through the vascular tissue that defines the airway or the air sac. Inhaling, exhaling, meaning is the same design no matter the direction of the air that rushes in. The direction could be the other way. Slaughterhouse floor. I grew up next to a slaughterhouse. Is the same design. Animal body coming in and body parts leaving the area, the floor. The auto assembly line is the opposite direction but the same design. Parts coming in, full automobile exiting from the other end. In fact, that's how Henry Ford got the idea for the assembly line. He got the idea by observing how efficiently operating were the slaughterhouses in Chicago 100 years ago. Now, why is the city not shaped like the Atlanta airport? Meaning, why is it designed like a grid? Well, it is designed like a grid because of, again, the Constructal Law. The city, the streets constitute a solid, rigid, temporarily rigid, expensive to make infrastructure. But in it, or through it, things are flowing temporarily. Here's a mass on Sunday morning. The whole crowd is converging on this side. Here's the crowd arriving at the train station at the end of the day. The crowd flows in the purple direction to the whole area. Public demonstrations, the schools in the morning, you name it. Tree-shaped flows, superimposed on tree-shaped flows, can be accommodated in the cheapest only one way, and that is the grid. The grid is not what's flowing; it is what's flowing through the grid that's facilitated, and that flow is hierarchical and tree-shaped. And you see it live if you play as I did with this waffle iron. You pour the batter on it, and you watch this movement invade the area, in this case, from the point of interest, over time. You take the picture, you overlook the complaints of the crowd, the line of people gathering behind you who want to use I did this in a motel, much to the exasperation of the people around me. And it took persistence because I was doing the pouring and also the photographing. See, doing science, amateur style, takes passion and it requires how should I say, taking chances. Okay. Now the grid doesn't have to look as perfect as in Manhattan. By the way, the grid was not invented in Manhattan. The grid was invented and built for the first time in the city of Rhodes. That is 2,500 years ago. This is another version of the grid that happened, boom, 30 years ago when Europe, following the example of the US, deregulated its airspace. So the long and fast are these red air routes. The short and slow is the yellow territory that's covered by the short and slow. The buses, the trains, the walking from the train station to the, say, hotel that's close to the point of unloading. But you see something else. When the long and fast is really long, like flying from, say, Paris to Moscow, the short and slow is also long, meaning the thickness of the yellow. The two go together. The tightness of the grid is most accentuated where the air routes are short, right? Say Paris to Brussels, and that means that access to everything in the armpit is also of short duration. The real activity in the human movement is where you see the concentration of red. That is where the action is, and that, of course, is the right ventricle of that two-chamber heart that I showed earlier. Okay, so that completes the second. See how simple my talk is? I'm explaining to you just the three words, okay? Constructal, thermodynamics, and now emotion. Going back to this story from childhood. So I went to the dictionary to find out why this word is so familiar to me. Of course it's familiar because, forget about the E. Delete the E. The word comes from a verb in French. And this verb in French means to agitate, to stir up. That's what emotion means. And by the way, in other words, it's not from English. English is not a language. English is something like Esperanto or Fortran. It's very recent, kind of made up by lots of other people who came to contribute. No. Okay. Emotion originally meant movement. This is why even in English, when we become emotional, we say, I was moved. Or I was taken aback. Or I fell off my stool. That's emotion. Emotion, by the way, sends entire peoples to war. Emotion is why cars move out of the showroom. You like them. You fell in love with this model, you buy it. And the model moves, you see. Movement begins with a decision or a trigger. Anyway, in English today we understand it also as a strong feeling, excitement, a complex reaction. These are the triggers. I'll show you some examples. The bottom line is that emotion is as much a feature or a part of what more broadly is the animal design of the human. And by the way, I'm sure that animals have this sort of thing themselves. It's not only about us, this third component of my talk. And so for example, why do we like things? This could, on the left, could be the business card of a tour operator in Athens. But, and I'm sure it is, but but it is also the photograph of the front image of the Acropolis. That's the way it was built, and there must have been a reason for it, because the horizontal dimension is called L from length, and the vertical dimension of the rectangle is called H from height. Then, surprisingly, the ratio horizontal to vertical is like 1.5, broadly speaking, 1.5 in everything. The frame of the film, when the Kodak film in my time when I was a student, computer display, the cinema, all these things are shaped the same way. Even those things that are tall looking, like the page of a book. The page of a book is in fact a construct of paragraphs that have this ubiquitous shape, or equation white spaces that have the same shape, or images, figures, inserts on the page that have this shape. If you put on a page like this a figure that's tall, a good editor will hit you over the hand with it. Said, no, we don't publish white areas in this expensive book. We publish things that are easy to read. Yes, so I paid attention to this advice when I was beginning to write, and I was able, and here is something that did not happen well in the electronics. It's a good thing it didn't happen. Here is the Atlanta airport again. How do we scan with our two eyes an area the fastest? Well, we scan it horizontally and transversely. We scan it with the two eyes, except that when we scan horizontally, what one eye does is taken up by the second eye and move to the left faster than one eye alone does the scanning on the vertical. Both eyes scan on the vertical individually. The two eyes scan on the horizontal in tandem, like two bicyclists pedaling the same bicycle. And so you predict on the back of the envelope that the shape of the image that is scanned the fastest by anything that has two scanners operating in unison should be the shape of the business card. And here this drawing had the ocular area covered by the two eyes, the two discs, separated by the distance between the focal points of the two eyes, and the average of that area, if you average it as a rectangle, ends up having exactly the same shape as this one. And so that's the origin for why people like these shapes that look rectangular. Actually, the ratio 1.5 happens to be the so-called golden ratio. Why golden ratio images are pleasing? They are pleasing because they allow us to grasp and get going. In other words, to live more easily. We like things that improve our lives. That's the source of, how should I say, beauty, if you want. Here's another constructal window into shapes. The pyramids of Egypt, and then the pyramids of Central America. When I was growing up, there were all these books, fantastic books, theorizing that Egyptians got into boats, crossed the Atlantic in order to teach the Mayans how to make pyramids. See, not the case. Making pyramids of only one shape is, in fact, the way to make pyramids. And here's this is a homework problem in Constructal Law, how to make a pile of stones. This is called dry stone construction, or pierre sèche in French, with least effort. Well, this is now you're walking on the concourse in Atlanta, on the train in Atlanta. The easy way to move a rock is to slide it with water lubricating the sand in front of the sled. And then the hard way, which is to lift one block with ropes and no pulleys, ropes and levers on top of the slide, that's the hard way on the incline. And so the sum of those two efforts is minimal when the angle of the incline is of a particular value, which in this case is shown here as the angle. Mu means friction coefficient, mu2, big, hard, difficult, mu1, smaller, easy, sliding. In other words, the angle, which is constant, and it has to do with the feelings of the army of workers, the angle is a sign of the technologies of the time. For these technologies, which were without a wheel, the angle is 1. Well, you may argue that the angle is not exactly the same everywhere, but I'm telling you, the angle to a person who likes drawings is one angle, okay? Which is kind of the angle between the 90 degrees and 0 degrees. That kind of an angle. Showing once again that all design is a trade-off between two extremes, both bad ideas. All right, another one, which is my most recent source of pleasure, is making how to build a fire of the best shape. This is not for the purpose of minimizing my effort of building. No, it's about the temperature of the fire. Temperatures on the ordinate, on the abscissa is the shape. Tall fire, shallow fire. You can show on the back of the envelope that the hottest fire is the one that's as wide at the base as it is tall. The reason is fluid mechanics in this case, because the fire has to be both tall to has to be tall to breathe, but if it is too tall, then all this cold air that comes from the sides cools it down. So very tall means cold, very shallow means it's not breathing, it's not acting like a chimney. So those two extremes are the bad ideas. We, in this case, the maker of the fire, learned a long time ago to make it this way. Why do I say a long time ago? Because the evidence is very clear. It is in the language. Let's go back to the pyramids. Why are they called pyramids? Because the Greeks used the word pira for the pyre, for the pile of sticks with which to make a fire. And my argument is that the Greeks were speaking Greek and making fire for much longer before they were able to take a look at the pyramids that the Egyptians had built across the sea from them. Get it? So, language is very important. Language is, again, to be known and appreciated before one, even before one learns science. And another, in fact, I'm getting close to the end of my excitement. I was predicting from the Constructal Law what the shape, the profile of the trunk of a tree should be. Well, the answer is obvious. It should be tapered, thin at the top, wider at the base. And in this case, the shape of the trunk is essentially insensitive to the shape of the canopy. So you have diversity in the forest, diversity galore, but that diversity is underpinned by features, which are these features of tapered limbs, trunk and branches. Branches are thin at the ends. And those two are underpinned by only one thing, which is the Constructal Law, which is, in the case of vegetation, the answer to the question is, how is this architecture putting water back into the dry wind, meaning putting the rain back into the wind? Well, the answer is through this architecture called vegetation. And that architecture has to be the best possible water pump, but also the strongest, mechanically strongest solid structure, so it is not broken or pulled to the ground by the transversal wind. So when I discovered this, it occurred to me, again, without trying, that I knew why the shape of the Eiffel Tower was in fact defying the various theories of investigators. The engineer, Gustave Eiffel, was very clever, not engineer, but in addition to being a clever engineer, clever businessman. He was not revealing the secrets of his edifices. Turns out that he did not build his tower, as most of today's scientists thought, is a structure that's one of maximum strength for compression, meaning weight compressing on the structure down below. His correct approach was to build the strongest tree trunk in the face of the strongest imaginable winds coming from the Atlantic, obviously horizontally. So the design of the tree trunk with compression considerations at the base was this one. And here I made the comment that had the engineer FL thought to design not only the strongest tree trunk, but also the strongest and most effective water pump, which is the tree itself, then he would have come up in Paris with the Eiffel tree, not the Eiffel Tower. Yeah. You see, if the work is good, then a good joke goes with it. Sorry, forget about if a good joke goes with it, maybe the idea is good. Okay? This is my most recent joke. Remember, people say, "Oh, diversity in animals, they're different. They have different names, right?" But when you decide to make them the same size, as I did here, I made these drawings, okay? And you say, "Wait a minute, they're diverse, all right, but they're diverse in a particular direction. The bigger, which now is as big as the cat, is mostly legs. The small is mostly belly." Ooh, I could have drawn a mouse here, and the mouse would have been basically a fur ball. almost no limbs. Amazing. Wait a minute. How about, forget about the runners, how about the flyers? You have here a tiny bird, one of these things, say hummingbird, looks like the mouse. Mostly look like a golf ball with vibrating fluff. Over here, the huge, say, albatross and stuff, mostly wings. Or swimmers, the guppy, tiny, mostly body. Over here, the whale, which is mostly tail. The bigger the fish, the more it is a snake. I don't know whether you swam with sharks. I did. I was in a cage, but the shark is all one tail undulating. The whale, the same thing. The whale for the swimmer is the lifting organ, just like the legs of the runner and the wings of the flyer. So, and then from the Constructal Law, now that's the punchline, it is easy to anticipate the fraction that the lifting organ should occupy in the total body versus the total body size. With greater body size, then the legs or wings or tail occupy more of the body weight. So that's what you get from making drawings and then questioning why, not questioning the drawing, but questioning the origin of diversity. Diversity does not mean randomness. It is predictable if you know the principle. All right, with this I'm getting to other people's work. As it turned out, these past few years have been the start and then success of a art current called Constructal art. I brought here 3 samples. One is from Juana Gomez, who is a much acclaimed artist from Santiago de Chile, and she does embroideries illustrating the human vascular design. That's her hand, and that's actually her face. Her embroideries are actually truthful. They're also beautiful, and they're world-renowned. There's another one, Maria Santos, an artist from Madrid. She does these things, in this case, tree-like architecture is done by dropping colored ink and blowing it without any instrument, just blowing, no pipette, none of that. It's simply her personal way of spreading the paint, and then she makes montages that illustrate, in this case, the oneness of animal and vegetation. And then here's a three-dimensional one from Kevin Banston, a graphic artist in Melbourne, Australia. Just watch this. Takes only 1 minute. About the city grid. It's not the grid, it's what flows through the grid from time to time. Okay. And now this is the table of contents of what I showed. I defined for you in physics the three words of the title and also of today's symposium. Along the way, I showed you the physics basis of evolution, life, not biology, but as physics, hierarchy, which is about images. And if you know all of the above, you now possess the secret of how to predict the future. Because the future is predictable with the laws of science. This is why science is useful. We all have to be honest about it. We all need to know and know better and know more because we're interested in stepping into this new moment or new day with greater confidence that we will live better tomorrow. That's the future. Thank you.
So we can have a short period of question and answer, if
Fine.
that's okay?
I'm at your disposal.
I have a question.
You got a question over here?
Yeah. So, I was fascinated by the assembly line piece. And more recently, there's been this whole new idea about for manufacturing around shifting away from that kind of manufacturing line to the cross-functional team that is all working together to build one whole product, and then putting it out the door, as opposed to it going along an assembly line. And so more of a swarm, which made me think about biology, and right? And so I have a feeling that there is a key in here for that shift, that there was a way to predict that shift, but I'm not quite making all the connections I need to make that happen.
I'm not familiar with this shift that you're sketching. I'm more familiar, obviously, with the things that called ahas
Yeah.
that I discover after I do this kind of work. Obviously, the assembly line is not what it used to be. And now the manufacturing is global. Forget about global. That's pretty obvious. The iPhone is made in China, and meaning that's okay. That's there are reasons for these new long and fast features of the architecture of manufacturing. We're moving newly manufactured products on the globe from production to the area that's occupied by a population of users. But even in the U.S., look at the automobile companies. The whole United States is like the factory floor of Henry Ford. There are spots all over the landscape that make things, parts, say generators or heat exchangers for the air conditioning system, and on and on. And these parts, these are the short and slow, converge on assembly factories, which may belong to Toyota or Volkswagen in places you never heard of before as automobile powerhouses, say Tennessee or some, okay? And that's the long and fast. They come, by the way, they come to the assembly part, and then from there they emanate in all directions according to this hierarchical flow that spreads. And it spreads because when these new products arrive in all these places on the globe, which here's the landscape is synonymous with population, okay? It's not the square kilometer, it's 100 people I'm talking about, but 100 people here in this location. Once arrived, this new device, car or iPhone, enables the population to move more easily. That's why technology happens. Technology is a great liberator. It makes a more powerful, longer living, happier living, all of this, individual. In fact, technology, the word itself comes from Greek. It is synonymous with mechani, which is a machine. Both of them mean the shirt. It means an artifact. They don't mean really an automobile or a revolver. They really mean anything like a pencil or a stylus in the old times that you attach to yourself to enhance the meager effect of human effort. Textile is the other word in this new language called English that is the same, has the same origin as technology. Texture, textile, technique, they all mean the same thing as mechanical, or machinery, or mechanism, or machination. Originally they meant the same thing. So, coming back to your example, I bet you that the reason is once again the Constructal Law, but I'm not familiar with the needs of human betterment that drive that seemingly counterintuitive new movie.
I would suggest that your original slide, one of your first slides that had the river, or the three slides with the different river systems, the first one being relatively high energy to get through the system might be your traditional manufacturing.
Right.
As you move towards the more swarming-oriented, lower energy, more branches. To
Yeah.
me, that jumped out.
Yeah, thank you.
Good point. In physicists today would describe that evolution as one toward greater complexity. Greater complexity, once again, does not mean more fuzziness or more randomness. It means, yes, greater diversity, in this case of scales, but they all have the same reason of existing. There is like an army that has become so big that it has more ranks than the first army had. By the way, here I just predicted the past history of the evolution of the army. It just occurred to me, okay?
Kevin has a question.
Well, could you add, could the Constructal Law kick in this way, that the advance of technology with robotics has freed up the worker so they can swarm and be more into the whole integrate, which would then gratify the emotional need of the worker.
Yeah.
So we could see Constructal Law benefiting the emotion of the worker. It's not, the mind-numbing part has been delegated to the robot.
Yeah, that's correct. I think that's the reason for that. And by the way, this goes back to your point. In today's world, the worker is not what he used to be. In today's world, the worker is, relative to 100 years ago, has a lot more free time. Yes, a lot wealthier. His or her hands are a lot cleaner. Okay? And on and on and on. And then what do you do when you have nothing better to do? You get together with other people and drink coffee, or I don't know what they do. They swarm. They swarm, yes. Wait. Larry first, and then...
Well, I just, the way my brain works, just kept rattling around in my head. But when I saw the pyramids and I looked down at this real simple observation, the Mayan pyramids, and then the angle of repose popped into my head. Do you know what I'm talking about? Okay, you got well, let's say you got a wheelbarrow full of gravel and you've got it up off the ground, maybe a couple, and you pour it, and then yeah, that's the angle of repose. And so I'm thinking that, especially the Mayan pyramids, looked like the angle of repose. Like
that is a coincidence. You're talking about...
coincidence,
yeah.
That's what I'm wondering. What is it, or is it?
No, this angle of the pile of granules that are poured on the ground, that angle is predictable from the mechanics of stability of granules that do not stick, sitting without rolling downhill, sitting on the previously fallen granules.
Right.
That is called, the field is called the mechanics of granular flow.
Okay, but I just, do you think there might be some relationship with the, just, the design?
No,
It just
no,
seems to, that's what I
no,
saw.
there is no relation because
Okay.
the stones in all these pyramids, by the way, all these ideas or urges come from the same Eurasia. Okay, the indigenous people of the Americas came from Asia,
Yeah.
and the making of grave sites shaped as pyramids is available on land from a period older than the Egyptian pyramids in Eurasia. And these things, these stones, are not these rolling granules.
No.
They are cut in a way that they stand one on the other in any arrangement you wish, like the building blocks that children play with, all the way to potentially tall objects to remain tall unless an earthquake strikes. You see, so they are not the kind of pile.
I was just looking at the stability of it, and then, well, like when the angle of repose, and I'm just thinking I'm not physics, but just in other words, to build that, it would seem like that, I don't know what the angle of repose would be for a truckload full of bricks dumped from a 20-foot height on the ground, but
Yeah, true.
just-
When you
I'm
dump
just saying-
when you dump something, including bricks. By the way, I've seen those accidents. Then during the dumping, anything that's not spherically shaped does roll down and makes a pile. By the way, when when knock on wood, a disaster strikes and a skyscraper falls to the ground. I grew up in a city bombed to the smithereens during the war. Every building that used to stand there was now a pile of rubble. The pile of rubble was the way that you describe this thing with the angle of repose.
Okay.
The shape of the side of the mountain with snow on it, that shape comes from the avalanches that constantly adjust all the way to the angle that you're describing, because that's the natural way of the thing, or meaning what's not stable, meaning sticking on the side of the roof, sliding off, and in this way it gives the shape of the roof. The pyramids have gotten there the other way around. They came from the ground and they got up.
Yeah.
They were not poured from Mars.
I was just saying this, well, thinking, I'll shut up, but it's like it's like it'd be more efficient, to build something like this, of course, the stability is an issue, but this is stable and it's more efficient, as far as your labor force to build something like this than it is to.
Yeah, today, the most efficient is to make it a skyscraper, because the making.
I'm talking about, thousands of years ago.
All the way to our era, the pyramid technology has evolved.
Yeah.
Now with reinforced concrete and with meaning
right.
steel reinforced,
Right.
and also with glass. Now the pyramid is a lot taller.
Yeah, thanks to elevators.
And that's the taller edifice has become Atlanta Airport aligned vertically. The faster the street called elevator, the taller the pencil, the skyscraper. The so-called diversity, this is a key point, is not random. It is a sign of the times, or for that matter, the complexity. And is in accord with well, it is predictable, because it's a reflection or a manifestation of the human tendency of moving more easily in space. For us, the space is actually three-dimensional. Everything that we see on the flat of a say urban design is in fact through underground, in thickly settled areas like Hong Kong, and above ground, like in all these other cities with skyscrapers. You had a point in the back, John?
Yeah, I had a thought regarding the swarm construction, because I thought of, immediately, like when you switched to nuclear swarm, I thought of deconstruction, and I thought of like the decomposition of ammo cartridges, and the decomposition of like wood matter by mycelium, following a similar specialized structure. There's lots of components that are really specialized, and they come in and they hit just the part that they need, and then they fall back while something else moves in and goes to the next state. And it's very, very progressive, and it looks like a swarm, but it seems to follow, as Tom was saying, the same flow structure that we see in the river systems and the deltas.
It's amazing to me that what you bring is, I haven't thought of it, I'm not aware of it, but now that you describe it it makes sense, like all these other things that I've discovered accidentally the same way by talking to interesting people over the past 20 years. The evidence, look, science goes this way, okay? The evidence is in plain view. There's really nothing new. What is new is the human ability to see this immense body of observations, to see it better, which means more simply, easier to grasp, and easier to implement into these add-ons that we call artifacts or technology or science itself. Science is an artifact. Science is like good art and or good magic tricks.
So this is, this is very like predictive, like you can kind of see the future and things
Right.
like that. Do you think you can apply this to, like manipulating the future? Like, can you, like, look at a flow system and influence things, like target key things to like influence like technological or political will to influence global warming? You know what I mean? Or do you think that the way of the world just kind of happens?
People, the so-called humans, used to be called people or men when I was going to school, they don't manipulate the future because the future is such that it must obey the laws. But the human animal is in the business of improving its niche. Its niche. All these things that we call technology and machines, it's the human niche. And the animal makes a better den for itself. That to us takes books and books to describe what it means. And I wouldn't call it manipulating. This is what people do. There's a saying where I come from, you sleep as well as you make your bed. You see, so making a better bed is what each of us does. However, this thing about manipulating the future is an idea that has occurred to politicians in the past, and they led to tragedies. Okay, the idea that I grew up under communism. That's one design that was supposed to be an answer to everything. Almost simultaneous, you had fascism, another design that was supposed to be fantastic according to the smartest people in Europe at the time. So what the Constructal Law teaches is to not, on one hand, to do the good things for your niche, but also to avoid making these huge mistakes. And the huge mistake is to think that you can, in fact, defeat nature. All engineering is about this. Engineering is not only about how to make the better, I don't know what, pencil. It is also about how not to make it. In the old days, the pencil was made out of lead. The school child would stick the lead pencil in his mouth. Now we know not to do that, okay? That's, okay, because it's poisonous. So engineering is also about what not to do. And when it comes to the future, it's okay to build the future so that we step into it because we are selfish, but to make sure that we don't build it in a way that ends up killing us. And that, of course, applies to the other things you bring up, global warming. It applies to all sorts of things, like running out of green spaces in the city, or running out of agriculture. That would be completely. But it's a concern because there are places on Earth that have run out of these things. So, or breathable air. Speaking of. Mispronouncing my name as Beijing. I heard that at the introduction. Yeah. So you see, it's a very good point. Very good point. And the answer that I gave you is obviously kind of long, but the question is much more important than the answer.
So my life's work is kind of like looking at these, like bird language, for example, like working with people who are like building ecological relationships to help people remember that, you know, we're part of the earth and that the things that we do have influence. So I'm trying to help people carve deeper channels into these directions of relationship with birds and nature. And their Constructal Law, am I making a difference?
Give these people you're advising the freedom to embrace and be embraced, and the freedom to change their minds, and the freedom to listen to their own voices. as opposed to the voices of someone who is allegedly wiser than everybody else, and on and on and on. In the end, is another punchline if you want. Yes, nature is all evolving design or all evolution, but there is no such thing as evolution in bio, non-bio, and social unless there is freedom. So you got to let everybody leave him alone, and he or she will figure out what's best, and then boom, out of the fact that everyone wants it better, you have the organization, you have the say the city design, the city council, you have science, you have schools, you have you have elections, you have democracy was not didn't come from the top, it was a natural design like the city grid. That's the big history of where we come from. It's not about 20 years ago or even 200 years ago. It's about long time ago, from the time that in fact define who we are. The acquisition and the control of fire is how we became different than those who were Homo sapiens before us. And that fire, boating, clothing, that's how spreading exploded on the globe. And what we discussed today, from pulleys to engines, is really recent, small stuff, uninteresting compared with the long movie of human evolution. Yeah.
I'm really fascinated by the idea of like the overlapping vascular structures becoming grids. Like, people going, to the train station is like one like tree-shaped flow, and then people going to the grocery store is a different one. How they overlap creates that grid. And then with what Diana was talking about with like this sort of swarm technique that's coming out in a lot of manufacturing, we have more inputs and flows that we're expecting from the workers instead of just like water coming downhill and branching out and doing just what water does. You have to consider the efficiency, like how much it's going to cost, like could I do this a different way? And it's like a more like complex system than here's an assembly line, here's the engine, bolt on the exhaust manifold. Here's another engine, bolt on the exhaust manifold. You have like simple inputs, simple outputs, but with this like more complex overlapping, there's a lot of flows, there's a lot of different things happening. You get that like complicated network connection.
Yeah, well, I bet you that even in this swarm that I see now emerging in my own mind, that there's architecture to it. Otherwise, you're going to end up workers stepping on top of other workers. But that development, meaning the swarm, is what you see in modern warfare. You have small groups on their own, making decisions on their own. And the reason, now you brought up the electronics, the communicating, the reason is that these intelligent units making decisions on the go are actually in contact with the rest of the campaign. And so these swarms are not solitary. They're actually communicating instantly with like swarms. There are swarms like the clusters of alveoli in the lung. They do their job, but they're actually not alone. What thrives is the whole factory or the whole company. And it thrives because everybody in it wants to live better. Business itself is a natural phenomenon. It is not imposed. And obviously, I'm talking about when you leave people alone, that's how business happens. Economics happens the same way. Participants want it better for themselves, and I don't know if you noticed, it's easier to make your way through a crowd when you attach yourself to the person in front of you, as opposed to elbowing your way through the crowd completely by yourself. How is that for the secret of social organization? Selfishness is the
Well, you know, and it seems too that, like with the swarming, I mean, what that is it seems like it's increasing degrees of freedom for the worker, the individual worker, which further vascularizes the environment, right?
Good
It
point,
pulls
good
more
point.
research, pulls their observations, their experience, things they're seeing at the top
Yeah,
of the
right,
system isn't
right.
seeing. So we're right back to the Constructal Law.
right. But for that individual freedom to manifest itself into better products and better ideas, you need to have this tooling that you bring up with the say robotics and the instant communicating and the instant correcting. You know, a mistake is caught, is not repeated. It doesn't end up like in the famous Soviet joke. One factory made left foot shoes and another factory made right foot shoes. You know, you see. So now we are answering your question. We're learning on the go. We're so free here and liberated by the Constructal Law that in the beginning we know nothing, and then when we say goodbye, we're experts on something we did not know beforehand. Yeah.
Sherry, you had a question?
Yeah, I'm dying to comment on that too. Because I work in that environment too,
Yeah,
I think that's, you can make immediate, the lower level decisions can be made much, much quicker that way. And it's the short and fast is much more efficient that way. For the low level decisions, you still need the high level decisions. It means emotionally more gratifying. You guys are both kind of saying that, but I think that because business is a human construct, we need the combination of the mechanical and the emotional, you know, where do they mesh? Where do they meet? It's much more emotional. But I did actually have a question. So going with the flow, I get why that feels good to go with the flow and why it's beneficial to go with the flow. But evolution seems to me like it's what happens when you go against the flow. So what causes you to switch from going with the flow to against the flow?
The movement itself is a flow, is the flow, and flow means relative motion. Flow means the mover being different than the surroundings that do not move. So every drawing is of two colors or more because of something is moving and the rest of the page is not moving. We in art, we call it contrast, or some other words, the thinness of the lines and the complexity of the assembly of lines, or how many scales, and many words like that. But the movement has configuration, and it occurs because the mover has gotten the ambient out of the way. I began with all the flyers, insects, birds, and airplanes. That movement is in place because it got the air out of the way. And the getting of that environment out of the way required power. You had to penetrate this body of fluid. That took power for two reasons. One is to overcome the so-called drag, which is the friction posed by, or the resistance posed by the ambient. The other one is that the flyer always has to lift itself over the body of material in front of it, because the body keeps falling, you see. So the body gets up. Every mover is a weightlifter, okay? So that's right. So it gets up and then falls. That requires, just like the falling stick. The falling stick, first the athlete has to lift the stick. That takes power. And then the stick falling forward gets the air and everything else around out of the way. So movement is always against. That's what movement is. Against. The ambient does not, the ambient opposes movement. This is the reality. If there is no movement, the ambient is still like the water at the bottom of the lake. And that is an image without a drawing, you see.
So if you apply that to thinking specifically, because that's what's hanging me up. If we're all thinking the same, but the person that evolves or gets more power out of the system or improves us is the one that now reverses the thinking or thinks differently.
Oh, you're talking about innovation here? Innovation.
Innovation is better than evolution.
Yeah, well, okay. First of all, in a society, this is a live system, meaning this is a population of people, meaning bodies that are alive, meaning moving, all with the urge of moving more easily. The innovator, for example, Henry Ford, sees a way to facilitate the movement of people. That his way is well known. Others, I mentioned the Romans with the roads, so a primordial way, which is to pave the road. By the way, paths existed from Eastern Africa. They had paths through the bush. Paths are where people walk, not the other way around. I mean, it's not like on a university campus where the university builds the path and then orders the students to walk along those paths. It's the other way, okay? But the Romans made them not only drivable, but permanent relative to the lifetime of the person. So the innovator, now going back to your point, is the visionary who sees a way of liberating the flow. The innovator makes the road or makes the car, and guess what? The flow comes to him. And that's why he gets rich, because remember, wealth is movement. I'm positive that in the beginning, the road was made by a person who wanted to his cart not to get stuck in the mud. So it was about his own cart being, moving more easily. Same with Henry Ford and everybody else. And anyway, the point is that's a new thing, an easier way to move, like the railroad and the iPhone and all these, or a bookbinding, or these things, okay, or a simpler alphabet, acts as an attractor to people who want the same thing. And again,
It seems like innovation is almost predictable. Like at certain points in history, multiple people will come up with similar innovations at the same time. So is that a buildup of stress in the system? Maybe this is a question for you. Is that a buildup of stress in the system, and so it's going to happen?
Good point. Actually, I like your metaphor with the stress. In other words, cracks tend to occur in a movement that's kind of stuck. Things are moving, just like the seepage in the wet mud, and then all of a sudden rivulets appear. Okay, and the rivulets appear, actually, this is the reality, they appear in many places in the wet sand. It is only later that they get connected into one tree-shaped flowing architecture. But when it comes to innovation, I think it happens both ways. It happens, first of all, the other way, which is that the visionary with the light bulb coming on is just one. In that case, Thomas Edison, or the Roman, paved the road. But it does happen in science, especially in this highly, scientists crawling on top of scientists, which is today's situation, that seemingly the same idea happens to more than one person. Maybe this happens by coincidence. Maybe it happens because of plagiarism. But the point is that what you bring up is more and more common. But no matter how it happens for the same reason and has the same effect, which is that of facilitating or empowering or enhancing the effect of human effort. And along the way, the visionary who in fact implements this new way acts as an attractor to flow himself or herself, and this person becomes more rich than the surrounding persons. You can fit in that little speech every story of innovation that you know.
Betamax versus VHS.
Well, yeah, wonderful. When I was a student, that was a big correct. Yeah, and if you ask me at the time, I thought Betamax should have won, but because it was smaller and. But back then, it wasn't the cassette that was cumbersome, it was the player. So it ended up a question of what company made it cheaper.
Could
The
that
box.
could that also have been a constructal law, was the PC was open to all developers, whereas the Mac constrained freedom. Only they could make their own software, had the access to the code.
I don't know. These things are questions for historians of that particular industry. From my interest, my life is different. Here's a joke from my profession. In academia, a good professor, I think I'm good, so this is about me. A good professor asks to the students, asks questions, only questions to which he knows the answers, okay? That's rule number one. Rule number two, which applies in my case, I tend to talk about things that I know, not things that I don't know. So I don't know this thing with Apple, even though I was one of the earliest Apple users, Apple I and Apple II, I was really a pioneer in trying the untried. But I did not become an expert. In fact, I developed I went back to my pencil and paper right after that interaction with that invention. So I talk about things I know, other than math. And things I learned going to school. I was sent to art school, so I know how to draw. So I talk about that, meaning the physics meaning of a drawing and how to make it. And I was a basketball player, so I know sports from the inside, from the mind of the person who not only sweats, but a person who wants to get better, and who grows up frustrated that he is not getting better fast enough, that the team is not getting better fast enough. So I learned about not just evolution, I learned about social organization, or for that matter, company functioning, all the way to civilization, from these very modest examples of organization. But I know them, you see, because that's how I was formed. So I talk about these things about drawings and the sports, not because I want to drop names or to show off. It's because that's what I know. I also talk about math, and I talk about history because I'm a fan of, meaning I've been attracted to these things. And yes, I do mention the F word called freedom because that was a big deal in my youth, meaning in my case it was the lack of. So that was a big thing. So that's in fact, this is the physics basis of evolution. It's important to know. You are still recording. I can't tell you more personal jokes, but I cannot resist. In academia, there are people who create, and we know who they are. They write stuff, and you read what they do. And then there are others who end up being administrators, and which is another body of creative people who come up every once in a while with rules and requirements disguised as good ideas for everybody, for all the other professors to follow. These people don't realize, meaning the people with the rules, that once you put, what do you call these things, hurdles or obstacles on the around the stadium, the race is going to get slower.
I like what you're saying there, because I see with large organizations, they tend to fossilize.
There you go.
They just make the existing rivers deeper. They don't grow. And so one of the things I feel like we can do to help those organizations is to shake them loose, to get the little tributaries running again.
Yeah, wonderful. By the way, Sherry, that's thank you very much. Thank you. Your thing with innovation, or my image of the thing that's flowing, but it's kind of stuck in the same slow flow, is this. What do you call this field? Organization or business organization.
Yeah.
This thing that's not changing is called groupthink. Okay, everybody finds it easier to agree with the boss or 3 levels of bosses above him or her, and that's the way to survive and to, in fact, prosper. Until one person who is honest or careless or stupid shouts that the emperor wears no clothes. That person ends up shot or kicked out of the company, or maybe he ends up owning the company.
In consulting.
I missed.
In consulting, yeah.
As an independent consultant.
Anyway, that's the phenomenon, and it fits perfectly in the way you brought it up first. It's amazing. These things are called connections. You see, one voice, or you with a swarm, says it first and says it one way, and then you have a chorus of 5 or 6 accompanying that in a slightly different pitch, and then you have an orchestra. You see, and I think this is very important. To me, this is very, very exciting. I don't know these things that you bring up.
Well, it seems like, one of the fundamental ways to support these flow systems and the vitality of them and the movement is captured in this freedom and degrees of freedom. Because when you get these rigid structures, a tree that's too rigid, a bridge that's too rigid, the Eiffel Tower rigid in the wrong way, then you get these stresses that collect, you get failures. So you get crises, a branch is pruned off traumatically, maybe the tree sickens, disease enters, or bridge fails and cars go into the water. So seems like part of the goal is to, keep the infrastructure from getting too rigid and giving it enough freedom to adapt, to vascularize.
It's true. This is. I'm glad to bring it up, because this is one image that has occurred to me, and this is definitely Constructal Law loudly. At the time of almost the same time with the Constructal Law, we had a hurricane in North Carolina. It was Hurricane Fran. It leveled about 25% of the trees in Durham. It had done much greater damage on the way to North Carolina, and we lost power for 8 days. It was to me a new experience. I knew about lack of electricity in the Romanian countryside when I was growing up, but this time was return to let's call it not primitive lifestyle, but it was very educational. But what struck me was that the streets are full of debris. There's no traffic, the trees had fallen all over. These broken limbs were of all sizes. There are a few trees that have been toppled, but the street was full of broken limbs of all sizes. Why? Why? Because these winds have been breaking trees forever and shaving them down and sculpting the tree architecture to what it is today. And on the way to making that drawing with the tree canopies and the Eiffel tree, in order to predict the architecture of the tree, you discover without trying that architecture is such that every branch, large or small, is sized and shaped such that it is of equal strength, meaning the cracking is likely to occur anywhere in the tree at the same time. Imagine this. This is not one flagpole that you can predict where it will snap. This is a multitude of these elastic sticks, and where the fracture occurs depends on chance. But what breaks could be large or small at the same time, which is when the wind blows. Just like in sports, this is the skeleton of the athlete is in fact this tree, solid tree. It's running, and forget that. It's like a walking tree. Remember this joke from Monty Python? I think it was the walking trees of Kilimanjaro or some joke like that. That's right. And these clowns were in the skit all searching with those colonial hats and binoculars to catch the walking or running tree. The human body has this weird skeleton shaped with these weird bones. Why? Because these are solid inserts of equal strength. When the body falls, the fracture could occur anywhere. That's why orthopedics is a specialty with a great future, because the need will always be there, and it is unlike the other thing in medicine, which is knowing where to cut to remove an organ. When it comes to fractures, before the X-rays, it was a very difficult territory where to apply additional support, where to put a cast and not put it in the wrong place, and on and on and on. Anyway, the human skeleton is designed in the same way, not only the sizes but also the shape of the bones and the curvature of the articulations. Pretty amazing, huh? In other words, those are not mistakes.
Right.
What looks weird in nature is not a mistake. It is the result of endless polishing through this accident after accident after accident.
Well, and the inside of the bone is a grid or a mesh too, isn't it? Like it's a
Exactly.
mesh.
The inside of the
So
bone
there's
is just
that
like
and
the river delta.
Right.
But to your point, you talked about rigidity of structure, and that would cause a fracture.
Mhm.
And I think about Galloping Gertie, the bridge. Too much fluidity in structure also causes a rupture of some
Right,
sort.
right.
So there's a happy
Yeah,
medium
go back to
somewhere.
those
It's not,
extremes and resolving the extremes.
Yeah.
In engineering design now, increasing the degrees of freedom, meaning building more freedom into the morphing of the object is the trend. By the way, that trend has been there forever, but now you see it more easily because of the computer-aided design techniques that we have. These are techniques that allow you to see the future design without actually building it. You can morph anything on the screen. You can try this, try that. In fact, you can engineer the morphing to lead you to the shape that looks like a human bone for one of these supports in bridge building or actually city construction.
Well, so we're gonna have more time for questions afterwards.